Suppose we have events m and n, where the probability of m is 0.25, the probability of n not happening is 0.6, and the probability of m and n both happening is 0.1. Determine the probability of m given that n has occurred, and determine the probability of n assuming that m has occurred. Okay, so we've got some conditional probabilities here. We need to remember the formula for conditional probability. We can do both of these together. Okay, so what's the formula we need? Well, it's the probability of the intersection of the two events divided by the probability of the given event, the known or assumed event. That's why it's very important to understand how to read it and understanding which one goes where, what it all means. Okay, so we're assuming n is true in the first one. We're assuming m has happened in the second one. Okay, now, in the question, they tell us the probability of both of them occurring is 0.1. We get the same numerator here. Now, we also are told the probability of m is 0.25. We don't have the probability for n, but we do have n complement. So we put in the probability for m. The probability for n, however, we're going to just work out off on the side. N complement has a probability 1 minus the probability of n. Okay, so what do you have to subtract from 1 to get 0.6? 0.4. Okay, so there we go. We've got our fractions all set up. Now, one thing we could do is convert the decimals here into fractions in order to better simplify. Although if you know how to do 0.1 divided by 0.4, of course you can just jump straight to that. Okay, remember with fractions we invert and multiply. Okay, so it's a 1/4, or you could write 0.25. So if I know n has happened, m has a probability of 0.25. Okay. And now 0.1 we could change to 1/10. 1/4 we could change to 1/4. Remember, invert and multiply. So we get 4/10 or 2/5, and this is 0.4. And there we go, our two conditional probabilities all worked out.